Okay, so we're going to continue our study of simplifying trig expressions and identities. So this will be our second set of example problems dealing with this. So you will need your identity sheet that looks like this, okay, for your reference. Okay, the first section says we're going to simplify the following expressions by multiplication. So when we FOIL this out, we should know how to FOIL that out mentally. So we're going to square the first term. So tangent squared, theta. Take the two middle terms, multiply it, then double it. This is 2 tangent of theta. And square the last term. Okay? So if you want to go out to the side and FOIL that out or box method it out, that's fine with me. But you need to be able to do this quickly. So square the first, take the 2 in the middle and double it, square the last. You're going to hear me say that over and over and over and over again. Okay? Now, tangent squared plus 1, if we go to our trig identity sheet, is secant squared, theta. Okay? So we get that from right here. Tangent squared plus 1 is equal to secant squared, theta. And you're done. Okay? That's as much as you can simplify it. Okay, so hopefully you've noticed difference of squares. In this next example problem, secant plus tangent, secant minus tangent. Okay, I'm just going to go through FOILing out. So FOILing is first, outer, inner, last. So secant times secant is secant squared. Outer is minus secant theta. Tangent theta. So your outer terms. Your inner terms is plus secant of theta, tangent of theta, and your last terms is minus tangent squared. Okay? These terms will end up canceling, and you're left with secant squared theta minus tangent squared theta. Now, that is actually equal to, so this is our Pythagorean identity right here. Tangent squared plus 1. I'll go out to the side and derive it for you. Okay, so if I want to solve for secant squared minus tangent squared, I'm going to subtract the tangent squared to the other side. So I'm left with 1 is equal to secant squared theta minus tangent squared theta. Okay, and that's just how you manipulate it. So this whole expression goes to 1. Okay, now we're going to go through some factoring stuff, okay, in the next section. And when we start the algebra unit of this summer pre-cal course, or just pre-cal in general, we're going to do a lot of factoring, okay? So I want to make sure that you know how to do that for your SAT. So, difference of squares. It's going to be sine plus theta. Sine of theta plus cosine of theta. And sine of theta minus cosine of theta. And that's all there is to it. The next one. So I need factors of 1 that give you a negative 2. So remember that a negative positive goes to, it factors to a minus minus. So it's cosine of theta minus 1 and cosine of theta minus 1. Okay? And it goes down to, or you can write it down like this. So that little trick I just taught you, square the first, take the 2 in the middle and multiply it, double it, which means multiply by 2, and then square the last term. Okay? So if you can start recognizing those patterns, your life will be a lot easier, especially if that middle term is doubled whatever this is, then you know that it's going to be in this pattern. Okay, tangent of theta plus sine tangent of theta. They have a GCF of tangent, so I'm just going to factor out the tangent. I'll leave it like that. 1 minus sine to the 4th. So I'm trying to think. I don't think that'll do you any good to simplify that anymore. Okay, so this is difference of squares too. So it's going to go to 1 plus sine squared of theta times 1 minus sine squared of theta. Now we should know from our identity sheet that 1 minus sine squared is equal to cosine squared. So that goes to cosine squared. And that's your answer right there. Okay. So generally you want to try and get everything down to sines and cosines when we're simplifying, and you'll get the hang of it. It's just going to take you lots of practice problems. Okay. Now we're going to start our identity section. So it says, using trig identities, prove that the left side equals the right side. Now, most of the time we're going to be manipulating the left side to equal the right side. Sometimes we use the right side and get it to look like the left. There's nothing wrong with that. Sometimes we have to kind of manipulate both sides, but very rarely. I'd say like 90% of the time, we're going to work with the left side. Okay, so I don't see any ones or squares, so I'm probably going to just go ahead and get it down to sines and cosines. So we got sine of x over cosine of x. That's what tangent equals. Okay, and I have a sign on the bottom. Now, I have a complex fraction, so from algebra 2, if I have a complex fraction, I keep the top fraction and I multiply by the reciprocal of the bottom fraction. So the reciprocal of sine is 1 over sine. The sines will end up canceling, and I'm left with 1 over cosine. And from my identity sheet, 1 over cosine is secant. Okay, so I've proved that the left side is equal to the right side. Okay. Now, just putting check marks by it doesn't mean that you got it right. The steps have to make sense. Okay. Next question. Tangent of x plus cotangent of x is equal to cosecant x secant of x. So I don't see any squares or ones, so I'm probably going to start by getting everything down to sines and cosines. Tangent is sine of x over cosine of x. Cotangent of x is cosine of x over sine of x. Now, we have fractions and we're adding and subtracting them. We have to get a common denominator. So this one's missing a sine of x on the bottom. And this one's missing a cosine of x. Okay? So sine times sine is sine squared. Cosine times cosine is cosine squared. And that's all over sine of x, cosine of x. Now, we should know that sine squared plus cosine squared is equal to 1. So we're going to go ahead and substitute that. 1 over sine of x and cosine x. Okay, now, so since the sine is on the bottom, 1 over sine is cosecant. And 1 over cosine is secant. And that's how we get our answer. Okay, next question. So we got 1 plus tangent of x quantity squared times cosine squared is equal to 1 plus 2 sine of x cosine of x. Now, I don't see a 1 plus a tangent squared immediately. Anytime it's quantity squared, you're going to have to FOIL it out first. Okay? So I'm going to FOIL this out mentally. So I'm going to square the first, take the 2 in the middle and double it, square the last term. Like that. Now, I know that 1 plus tangent squared is equal to secant squared. like that. Now, I can't use my Pythagoreans anywhere else, so I'm just going to go ahead and break everything down to sines and cosines and distribute. Okay, so let's go ahead and distribute first. Do that first. So we get secant squared x times cosine squared x plus 2 tangent of x cosine squared x. Now, we can rewrite secant squared as 1 over cosine squared okay, so those will end up canceling and you're left with a 1. Tangent can be written as sine over cosine. And I have a cosine squared on top. Now one of these cosines will end up canceling. And I get my answer. Like that. Okay, next question. Now, whenever I see addition, subtraction of a fraction, I have to make sure that I use a common denominator, okay? So this one is going to be missing a 1 plus secant of x. And this one's going to be missing a 1 minus secant of x. Okay, so we're left with 1 plus secant of x on top plus a 1 minus secant of x all over 1 plus secant of x times 1 minus secant of x. Okay, the secants will end up canceling on top and we're left with the 2. Now, we should know that this is going to be a difference of squares. Okay, so we can FOIL that out. And this is going to be 1 minus secant squared x. Now, on our identity sheet, tangent squared plus 1 is equal to secant squared theta. So I'm going to write that out to the side and show you how to manipulate that. And if you want to add that somewhere, feel free to add whatever we derive out to the side. I don't expect you to spend a ton of time doing this on your own. So I have to get 1 minus secant squared. So 1 minus secant squared theta. So I'm going to subtract this to the other side, and I'm going to move this tangent to the other side. Okay. So I'm left with 2 over a negative tangent squared theta. That 2 looks horrible. And I'm trying to get it to cotangent. So 1 over tangent from our reciprocals, 1 over tangent is cotangent. So this is going to be a negative 2 cotangent squared theta. Oh, x. Sorry, these are x's. X. Yes, you have to write your angle if you're going to ask me that. Yes, you have to write your angle. Okay, last 2 examples here. So, on this top example problem, anytime you only have one term on the bottom of a fraction, we can split the fraction up. Okay? So, we go cosine of x over sine of x minus 1 over sine of x. Cosine over sine is cotangent of x. 1 over sine is cosecant of x. And we're done with that one. Okay. Trying to think the best way to do this one. Okay, so I think the best way to do this one is going to be multiplying by a conjugate. Okay, so if you don't know what a conjugate is, the conjugate of this is going to be 1 plus sine of x. Okay, it's the same term, you just change the sign in the middle. Okay, so 1 plus sine times 1 plus sine is 1 plus sine of x squared. Okay, 1 plus sine times 1 minus sine is 1 minus sine squared of x. Okay, we're going to leave the top alone for just a second, and then we're going to deal with the bottom. 1 minus sine squared is cosine squared. Okay, so what we're going to do is, it's probably easier to FOIL this out mentally. Okay, 1 plus 2 sine of x plus sine squared x all over cosine squared x. Now what we're going to do is we are going to split this fraction up, okay, mentally. So 1 over cosine squared is secant squared x. A sine over cosine is going to give you a tangent. And you're left with 1 cosine on the bottom, so it's going to be secant of x. Sine squared over cosine squared is tangent squared. Now, if I was to factor this down, I should get this side, okay? So, and I know it's going to factor like that because the term in the middle is double. So, just double checking myself. If I square the first term, I get secant squared. I take the 2 terms in the middle, I double it, and I square the last term. Okay? So this was a tough problem. You're going to have 1 or 2 of these that are a little bit more difficult. If you wanted to check yourself too, you probably could have got to like this step right here, and then I could have FOILed this out and got it in terms of sines and cosines and been okay on this. It just depends on which way you want to work it. So this has been Trig Identities notes, and I will, for all your practice problems on this stuff, you'll have answer keys. So if there's any question on, hey, how do I do this? Just let me know, and maybe I can work out some additional videos for you. Thanks, and have a good day.